Hi gang, we're going to do section 3.6 number 63. We're going to find the slope at this point on this function. I wrote down the formula for the derivative of the arctan. Okay gang, so let's go ahead and find the derivative. So derivative of x squared is 2x. When we get to this part, we have a variable times a variable, so you're going to have to use the product rule. So that's what you're going to see me do now. So first times the derivative of the second piece. So I have to take the derivative of this. So I'm going to start with the, I'm just trying to find the word so I don't confuse you. Okay, I'm just going to take the derivative of this. So this is u right here. So u prime is the derivative of this. So the derivative of y is dy dx. Again, the derivative of y, this is u, is dy dx over 1 plus u squared, so that's going to have to be 1 plus y squared. Alright, so that's the derivative of the arctan. So it's first times derivative of the second piece plus second piece times derivative of the first piece equals, okay, derivative of y is dy dx, and derivative of a constant is 0. Alright gang, so it just really depends how much, some students will plug in at this point and they find it easier to simplify it from there, or you can go ahead and isolate your dy dx's. Now if you do that, I think the easiest way to do that is to first get rid of the fraction. So my point is it's going to look messy no matter what. So I'm going to multiply everybody by this denominator to get rid of the fraction. And again, the only easier thing to do is to just plug in now and simplify. And I will probably do that so you can see it, because that actually is the easiest thing to do. But for those of you who want to algebraically isolate the dy dx without plugging in, I'm going to show you how to do that. Alright, so on this one we're going to cross out this guy with this guy. Just trying to fit a dy dx there. Hopefully you guys can see that. Okay, so now we got a dy dx here, a dy dx here. So we're going to get them both on the same side. So I'll probably just move this dude over there. So you can see why I was just gonna, like if I was taking the test and I wasn't required to isolate dy dx, I just needed to find the slope, I would have just plugged in right here. Because as you can see, the algebra just gets so massive. And it almost gets to the point where it's like a little hard, you know, it's like a little hard to manage it. You guys just carry this line down so I don't have to write all that out. And I know you guys see this part because I know how smart you guys are. You're gonna, yeah, you're definitely gonna factor that out. You don't want that hanging out in there. I mean, you don't have to factor it out, but it looks a lot cleaner like that. Okay, so like that is the algebra nightmare if you're going to go there. But I would suggest on these, if you're not required to isolate dy dx, you just go ahead and plug in. So there's so much going on here. Let me just go back to where we wrote the derivative. Okay, so what I just grabbed here is when we actually did the derivative right here, and I'm going to grab the point, which is negative pi over 4, 1. Okay, so let's just find the slope here, and then so this is another way you can see how it's done. So 2 times negative pi over 4 plus negative pi over 4 times dy dx over 1 plus 1 squared plus arc tan of 1 equals dy dx. So we are still going to isolate dy dx, but we're going to isolate it after the plug-in, and we usually don't do that. I'm only doing it because it's so messy. It's not like highly advisable to do that. But in the cases where it's so messy, it's just easier to do it that way. So we sort of get away with it because of that. My hand likes to change the numbers every now and then. I've got to keep an eye on it. Okay, 1 plus 1 is 2, at least today. Arctan of 1, that's got to be a pi over 4. Okay, because the tangent of pi over 4 is 1. Remember, they're inverses. Alright, so I'm just sort of squeezing it like one little thing at a time. If you want, you can go ahead and add this. That would be negative pi over 4. You can go ahead and do this piece. This would be negative pi over 4 divided by 2 would be negative pi over 8 times dy dx. Just depends how you want to solve this. You could knock out the fraction now if you want. If you're going to knock out the fraction, you're going to multiply everybody by 8. Okay, you can probably guess where I'm going here. I'm going to move this guy over. Okay, it's more manageable now. We're going to factor out the dy dx. We're going to go get a Tylenol for our headache. Okay, we're almost there. Gonna divide that guy off. Woo! Okay. Congratulations, we did it. There you are. That is the 5 pages later answer to number 63. So just again to point out, if it's going to be like a really messy scenario, sometimes it's easier just to plug in and then isolate dy dx. Otherwise, the algebra could just start to explode on you as you can see, that's what it did to me. Not that you guys can't handle it. By the time you're in calculus, once you survive pre-calc, your algebra skills are sharp. So it's not like you guys can't do it, but it might just be like, if it's not necessary to isolate it, then to just go ahead and plug in and isolate it. Alright gang, that's it on this one. Catch you. Bye-bye.